Welcome to Sravz Technical Series. In today's session, we'll discuss Boost Beast REST API Server and its support for cross-origin resource sharing or CORS. And this allows us to enable high availability of these services. So today's discussion is based on the support provided by Mozilla. So cross-origin resource sharing is required so that we can enable high availability of services, like I mentioned before. So all these days we were going through the technical implementation of a Boost Beast REST API server using C++. So this is the link to that discussion. We have a bunch of topics discussed, and after topic 9 we segued into the Airflow Dask, and this is today's session. In today's session we had to implement cross-origin resource sharing because our services are served from different domains, and Boost Beast REST API server has to support CORS or else it cannot be deployed to production. So before we delve into the code base, I'll give a quick demo. So at Sravz page, at CORS page, we have Sravz YTD page. If you click on that, it opens year-to-date analysis page, or you can access year-to-date analysis page from the Analytics tab, Analytics link, and it's year-to-date analysis. Right now, I implemented only for the stocks. Eventually, I'll implement for mutual funds, ETFs, and every code that is supported by Sravz. So, for example, if we select a stock from the grid, in the stats page, we show various stats. For example, for Accenture, for the last 10 years, 722 to 718, 2013 to 2023, last 10 years, the annual returns were 17%, annual volatility was 24%, etc. Sharp ratio, Kalmar ratio, etc. So we display this bunch of ratios for each individual stock over last 10 years. So this is the stats grid, and the raw data is shown here. If you look here, it has a bunch of statistics for last 10 years. And this data is served over Boost Beast REST API server, which we developed in the previous sessions. Now at a high level, CORS allows cross-origin resource sharing. So for example, if we have a website served at this domain, for example, domain.a.com, and I took this sample from Mozilla site, which I linked here. So for example, if we request a page from domain-a.com, and at the same time, we also request another image from domain-b.com in this browser session, then the web browsers would not allow it because it's a different domain. The browser URL has domain-a.com, which you see in the URL like this. And then internally using AJAX, asynchronous Java call, when we fetch something from another domain, the browser doesn't allow that. So to allow this resource sharing between domains, we have to implement cross-origin resource request. So I'll switch to the Sravz website and I'll demo how that works. So for example, I have the developer console in Chrome opened. Say for example, I request Adobe. Then this is the headers. So I'm at sravz.com domain, and these statistics are hosted at codes.sravz.com. It's a different domain. This is a different domain, and this is the original domain on which we requested the web page. Since we are doing cross-origin resource request, we have to implement CORS in the web server, which I did in the Boost Beast REST API server. Once I implemented that, I'm able to get proper data from the cross-origin. So I got a 200 response code for options request, and then when the actual get is done, I got a 200 response. So I'll explain how the cross-origin resource request works. When we do a cross-origin request, for example, again, I requested for Acuity brand, the browser will first send Acuity. Okay. The browser would first send an options request. When an options request is sent, the server has to respond with these headers. The server responds that it allows credentials in the headers, then what all other headers it allows, and what methods it allows, HTTP methods, and which origin is allowed. So the browser has responded that it allows get, and then it also allows this origin, which is our original origin. Once the browser responds, once the web server, which is our REST API server responds with these headers, and we get a 200 HTTP code, then the browser, in this case, the Chrome browser, will perform the actual GET request. And in the actual GET request, we get the data. So this is the response I get for the request. So you see the same ratios which I discussed here in the previous browser session. This data is sent by the BoostBeast REST API server. So if I go back to the headers, you can see the server is BoostBeast REST API server, and it also gives the date, etc. So with that, our BoostBeast REST API server we developed supports cross-origin resource request. Now, why do we need this? This is implemented on certain servers, and the codes.sravz.com is implemented on a different set of servers. So this way we can span out, we can put more backend servers, and then this server is primarily focused on serving the HTTP pages, and this server is focused more on doing some analytics and generating these ratios, etc. So more CPU intensive. So we separated out this workload so that our web browser, the UI always displays with some data, and the CPU intensive works or the background workers don't overload the web browser. And so if the web browser is overloaded, then you wouldn't even get the initial page. So we want at least the landing page, the initial page to load. And if the backend servers, in this case codes.sravz.com, is overloaded, we won't get this stats data, but at least a simple UI is displayed. And later on we can do error handling and display in the UI that the backend server is down, or etc., so that it gives a better user experience. So I'll switch to the code. In the source code, we have gone through this http_sessions.cpp file before. So this whole code has been discussed in the previous sessions. So in today's session, I'll just highlight the code that was changed. In the options response, we now send the allowed headers. So these are the access control allowed headers we send. Then the allowed methods are sent. Then we have to send this access control allow credential true, because our authentication based on bearer token. So if this is not set to true, then the GET request cannot send a bearer token in the request. The client, the Chrome browser, will reject it if we try to send a bearer token to a server which has not set this header. Then the client will reject that request. So we have to set this true if we are sending bearer token in our request headers. And the cross origin. To allow any origin, we could set star per Mozilla document. So for example, if I set a star here for allowed origins, then any domain can request the data from the BoostBeast REST API server. So to prevent that, we only send the origin which we allow. In our case, we want to allow request from https.sravz.com, which is this domain. We want to allow requests only from this domain. So for that purpose, what we do is we pick the request headers. From the request header, we pick the origin, which is https://sravz.com. From the request header, once we origin header, field.origin, request.find, we get our origin. In our case, this one, https://sravz.com. So we pick this from the request, and then we maintain a vector of origins we allow, which is in this allowed origins vector. In that vector, I have listed Sravz.com and some other host names. So each time we get a request, we pick the origin header from the request and we check if that origin is in the allowed origins vector using std find iterator. Then we check this normal find operation in a vector. If the iterator is not to an didn't go to an end, that means we found a origin in the we found the request origin in our vector. If so, then we set this origin, the origin which we got from the request, this origin, right, back in the allow control access origin. So instead of setting a star, we set the origin which originated from the request after we search within our list of allowed origins vector. So this way we restrict cross-origin requests to only specific origins so that's how the allowed origin works for the options response. Similarly, for the get response or any other response where we have discussed in the past, in the previous sessions, we do a context switch and send the request to the background worker so the background worker does the actual work. So in that function, we also do the same logic. So we get the origin header, then we search for the origin header value in the list of our allowed origins. Only if it is found, we set the access control allow origin to that origin. So that way only a specific set of origins which is defined in our config file are allowed. So this is to avoid star. Star is not a secure way of allowing, because that would allow any origin to do request to the web server. So with that, I conclude today's session. Please let me know if you have any questions or comments. You can reach me via the YouTube channel or in the comment section here. Thank you for watching.